Okay, so we are finishing our notes on section 4.3. Last time we started looking at the fundamental identities and we talked about the reciprocal identities. Sine is equal to 1 over cosecant, cosine is equal to 1 over secant, tangent is equal to 1 over cotangent, and so on. But the fundamental identities are not just these reciprocal identities, they also include quotient identities. You remember the tangent, if we're looking at the unit circle, the tangent is the y over the x. But since y is the sine and x is the cosine, that means we can write tangent as sine of theta over cosine of theta. And that's a quotient of two trig identities, right? Two trig functions. So what about the cotangent then? Cotangent's going to be what? Stephanie? Well, cotangent, can we just take, instead of y over x, can we just take x over y? So what would that be? Cosine over sine. Are we okay with this? Danny? Cofunctions of complementary angles is an identity. It's a different type of identity than the quotient identities. So sure, I mean, we talked about like the cosine of theta is equal to the sine of 90 minus theta. We looked at those last class. This would be like a cofunction identity. I mean, we don't really count the cofunction identities as one of the fundamental identities. The fundamental identities are only going to include reciprocal identities and quotient identities and the ones that we're about to talk about, the Pythagorean identities. You, I'm glad that you asked that. You will need to memorize these for chapter 5. Because chapter 5 is all sorts of verifying trig identities and so forth. For our purposes, I don't think I'm going to ask you to memorize these for like a quiz on 4243, for example. Okay? All right, so let's take a look at these Pythagorean identities. The Pythagorean identity, sine squared plus cosine squared is equal to 1 is one of them. And let's just take a look at an example. You know that if theta was equal to, I'm going to say pi over 3, and you're looking at your unit circle, for example, and you're saying, hey, pi over 3 is right here, right, where the ordered pair is going to be 1/2 comma square root of 3 over 2, correct? Right? So if I wanted to test this Pythagorean identity, my cosine of theta is equal to the x, that's the 1/2, and my sine of theta is equal to square root of 3 over 2, correct? So is it true that the sine of theta squared plus the cosine of theta squared is equal to 1? By the way, when we write sine squared theta, what we really mean is the sine of theta quantity squared. We're not squaring the sine, we're squaring the sine of theta, right? We're squaring that, but it's just easier to write it this way. We don't need parentheses then if we write it like this. So here's what I'm asking you to check right now. If I take sine of theta, that's square root of 3 over 2, and I square it, that's this part, and I add to it the cosine, which is 1/2, and I square that, do I really get 1, which is what I'm supposed to get? Can we check this? I didn't leave myself much room here. But if we're checking this, square root of 3 squared is 3, 2 squared is 4, right? And 1/2 squared is 1/4. Does that equal 1? You betcha. And it's going to work no matter where you are on the unit circle, no matter what angle you're talking about. The sine value squared plus the cosine value squared when added together is going to give you 1. Jacob? That's right, because exactly, because we're talking about a triangle here where the hypotenuse is 1, and this is your cosine, which is 1/2, and your side length here was 1/2, and this side length is square root of 3 over 2. So that's exactly where these are coming from. Oh, that's good for Smarty. Okay, all right, and the other two Pythagorean identities are 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. And I already pointed out sine squared theta means sine of theta quantity squared. All right, let's take a look at this example. Let theta be an acute angle such that cosine of theta is equal to 0.96. Find the values of the following by using the trig identities. Okay, so if I want to find sine of theta, and all I know is cosine of theta, which one of these identities, these basic trig identities, reciprocal, quotient, or Pythagorean, only involve sine and cosine and no other trig function? You're looking them over, Kevin. The Pythagorean. Which one? The one we were just working with? Okay, so if that's our case, then we're going to plug in 0.96 for cosine, and we're going to square it, and we're going to add it to sine squared of theta, and that has to equal 1. Everybody with me? Jacob? So you're grabbing your calculator, and you're going to do 0.96 squared, because we're trying to find the value of sine of theta if we know cosine of theta. And notice it does say let theta be an acute angle, so we know that theta is somewhere between 0 and 90, so we know we're in the first quadrant. So cosine's positive, and sine also has to be positive if we're in quadrant 1. Danny?
So 0.96, is that a sine measure, angle measure, a radius measure?
No. It is the value of the cosine of some angle theta. So if you want to picture it, there's some angle between 0 and 90 degrees where the cosine is equal to 0.96.
So that's, what, is there a unit that it's in, or it's just?
Yeah, just number. Okay? I mean, you could think of it as a length somewhere between 0 and 1. It's 0.96 if you want. So what did you get? What's 0.96 squared? 0.9216. And I get sine squared theta plus 0.9216 equals 1. You're solving for sine of theta, so we're going to subtract 0.9216 from both sides. And we get that the sine squared theta is equal to what? 0.0784. And now what do? Take the square root of both sides. The square root of sine squared is just going to be sine of theta. Now technically it's plus or minus, right? But remember, we're in quadrant 1 because it says it's an acute angle, so that means theta has to be between 0 and 90, right? So we know it's going to be positive. If they had said, hey, this is in quadrant 4, well then cosine is positive in quadrant 4, but sine would be negative in quadrant 4, right? So what about this? What is the square root of 0.0784? 0.28. So that means that the sine of theta has got to be positive 0.28 because we're in quadrant 1. Are we okay with this? That's all for A. Now, if we're trying to find B, and of course I ran out of room here.
How did you get the points right again?
Let me slide this down. What's the question? Are we, so in order to find the answer for B now, we want to find the tangent of theta, which trig identity involves tangent and cosine, and now we could use sine also, because we have the value for sine and we had the value for cosine. So which trig identity involves those, Danny? Okay, tangent equals sine theta over cosine of theta, and we know that the sine of theta is 0.28, and we know that the cosine of theta is, what was it? 0.96, was that right? calculators, what do you get then for the value of tangent of theta? Jacob?
Get 0.2916.
0.2916 with the 6 repeating. All right, then let's just round to 0.2917. Are we okay with that? Questions on this? So this is a way that we are using the trig identities to help us find other trig values if we know a few of them. Okay, so let's take a look at a different use for trig identities. This says use trig identities to transform one side of the equation into the other, and it says note that theta is between 0 and pi over 2, or between 0 and 90 degrees. Okay? In section, let me start over. In chapter 5, sections 5.1 and 5.2, which we're not going to get to until, January or so. But in those sections, you will need to have the basic trig identities memorized, these fundamental trig identities. And a lot of what we do is going to be to try and transform one side of a more complicated trig identity into the other side. Okay? So we're going to usually take the more complicated side, like it looks like the right side of this is more complicated. Is there an identity that you kind of recognize here on the right side? Like, for example, I know we don't have an identity for 1 over sine squared, but do we have an identity for 1 over sine?
Yeah.
What is that? So really think of this as 1 over sine theta times 1 over sine theta. Wouldn't that be the same as 1 over sine squared theta? Right? But each one of these is what? So really we're trying to say cotangent squared, that's my left side, is equal to cosecant theta times cosecant theta minus 1. Would you agree with that? And is it okay to write cosecant theta times cosecant theta as cosecant squared theta? Okay. And do we have an identity about cosecant theta? For example, can we use this identity right here that says that cosecant squared theta is equal to 1 plus cotangent squared theta? Agreed?
Yeah.
So we're going to replace the cosecant squared right here. Come on. We're going to replace this right here with 1 plus cotangent squared theta. And we still have minus 1, and we're still trying to show that this is equal to cotangent squared theta. We're going to use whatever identity. It's kind of like the identities are like the tools in your tool belt, and you're going to just pull out whichever one you need for that particular job. Okay? Where do we get what one from? This one? Oh, because the identity says cosecant squared theta is equal to 1 plus cotangent squared. So now, is it okay for me to say, hey, these ones here are going to subtract off, so I get cotangent squared theta equals cotangent squared theta. And we're done, because we've shown that we can simplify this right side using the identities and get it to look just like the left side. Danny.
Like, how would we solve, like, for a number?
In this particular problem, you're not solving for anything. You're just showing that you understand the identities enough to manipulate them and rewrite an equation so both sides are equal. Alex?
So we need to memorize these
Yes. Future test, yes. This particular quiz, I'll let you know if you need it this semester, but you'll definitely need them second semester.
So what is, like, we want to try to end up with, like, each other?
Yes. Yes. And we'll talk more about this. You're only getting a little taste of these verifying identities in section 4.3. You get a whole banquet of it in chapter 5.
Oh, yeah.
Okay? All right. So I'm going to stop this lesson right now so we can take our quiz.